Welcome back to Geometry Nirvana, or Mr. Nard's geometry class, whatever you want to call it. And so here we are, we're looking at section 2.2, conditional statements. Okay. So it's important to realize conditional statements have two parts. So conditional statements look like this. If blah, 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 then blah, blah, blah. So this part right here is the hypothesis. And this right here is called the conclusion. And being the ridiculously lazy mathematicians that we are, this is how we do it. We go P to Q. P right here, that's the hypothesis. Q right here, that is the conclusion. And so we would say this, if P, then Q. That's how that works. So moving on. So we're going to start off, problem set was 5 through 24. So there are a couple different ways we can do this. So first things first, the first one is if, this is number 5, if you are an American citizen, then you have the right to vote. As someone accurately pointed out in class, this is actually a false statement. The counter example being, if you've been convicted of a felony, you do not lose your citizenship. However, you do lose the right to vote. That's not the issue here. We are being asked to identify the hypothesis and conclusion of each conditional. Pretty straightforward. This right here, the if, that's the hypothesis. The then part, that's the conclusion. So I'm going to highlight here really quick. Green, conclusion. Jillian, pick a color.
Red.
Red. My son, Jillian, picks the color red. So from now on, whenever we do this, red is the color of hypothesis. Green is the color of conclusion. Or more specifically, red is our P, and green is our Q. Note, if you have red P, see a doctor. Okay, moving on. Next, we have write each sentence as a conditional. So this is numbers 8 through 12. Now, these are kind of tricky, and I'm going to pick the toughest one here, and I'm going to show you how I did it. Now, I want you to keep in mind that there are probably multiple ways you can do this. You can go and switch things around. I'll give you a couple of ones that are examples, but I'll also show you how I did it. So the statement is, Hank Aaron, or Aaron, if you're so inclined, broke Babe Ruth's home run record. And that is true. And so this is what I did. Okay, so we need it to be if P, then Q. So I'm going to put that our hypothesis here, our P part, is if you are Hank Aaron, and then we just need our conclusion. Then you broke Babe Ruth's home run record. Okay, so notice we have that if part right there. We have our hypothesis. That's our if you are Hank Aaron. And so how this works is if you are Hank Aaron, then So you have to be of that set of people who are Hank Aaron. There's only one Hank Aaron. Then you broke Babe Ruth's home run record. So it's that automatic. If you fit that first part, if you are part of the hypothetical class of people or things which fit that first part, then the second part must apply to you. So that's how 8 through 12 work. And 13, 14, 15. Okay, so what we're talking about now are conditionals illustrated as a Venn diagram. Now, I don't particularly like this, but some people use it, so I'll quick show you how to do it. And it's pretty straightforward. So it may seem a little bit backward, but trust me, it makes sense. So we have a circle here, and notice that our hypothesis is inside of so red's inside the green. So again, we're looking here and we say if P, then Q, right? And if you look at that, that kind of makes sense, because there's no way you can be inside this P bubble without being inside this Q bubble. I mean, you can definitely be inside this Q bubble without being inside the P bubble. I'm trying not to giggle every time I say P bubble, just so you know. You can't be outside of that P area without being inside the Q area. So that makes this a true statement. If there was a way that you could be part of that group of people who are, P, or in this case Hank Aaron, without being in Q, then you'd be able to go ahead. But this is a true statement. So when we're looking at the first one, and sorry about that. The first one, it's got this little kind of, I'm going to call it grayish, and then blue around it. That's not going to work. There we go. And you have blue in here, and then colors on the outside. And so the statement that would go along with that would be, you want to write your hypothesis first. So remember that this right here, that's our hypothesis. That inner circle's our hypothesis. So we'd say if something, super specific here, is blue. Okay, so that's our hypothesis. And now we want to flip over and we want to go then. Nope. We want to switch back to green for our conclusion. Then it is a color. And that's it. If something is blue, then it is a color. 14, 15, again, if a number is a whole number, then it's an integer. So we then go on from 16 to 18. 16 to 18 says, determine if the conditional is true or false. If it is false, find a counter example. Number 16, if a polygon has 8 sides, then it is an octagon. Well, that's true. Can't have an octagon that doesn't have 8 sides. So what you're looking for is something that fits within that first category, but not the second category. Again, if we look at things for counterexamples, go back, and my previous slideshow has some stuff on truth value and counterexamples. So now what we're looking for is, so let's look at one. If you play a sport with a bat and a ball, then you play baseball. So counterexamples to that: softball, cricket, things of that sort. So all you have to do is find one example, and you just write it down. So 18, I would write cricket. and false. That's it. Super easy. And finally, okay, so 20, 21, 22, and 23. They talk about inverse, converse, and contrapositive. So let's go back to our original statement, and we'll talk a little bit about that. If you are an American citizen, then you have the right to vote. I'm actually going to pick something a little bit different. We'll just go through and do it with number 20. Okay? So number 20 says, if you are a quarterback, then you play football. So what we're going to do is we're going to say if the given statement is not in an if-then form, rewrite it, and then write the converse, inverse, and contrapositive, and determine the truth value of all four statements. If a statement is false, give a counter example. It's a lot of work. So I'm actually going to walk through both 20 and 21 with you. I'm going to do 20 because it's already set up as an if-then statement, 21 because it is not. Okay, so let's go. If you're a quarterback, so remember, we have our P's and our Q's here. So that's our P. If you're a quarterback, Q, then you play football. So this is called our conditional. And that is written as if P, then Q. And that is true. Can't be a quarterback without playing football. No counterexamples, true statement. So put a little T out on the side. So now we're going to talk about what is called the converse. Now the converse happens when you switch Q and P. So instead of saying if P then Q, we're going to switch these two. So it's going to look like this. It's going to be if Q, then P. And that, again, is called the converse. And so the converse of that would be if you play the football, then you are a quarterback. And that would be false. But notice, specifically according to the colors, what we've got going here. So that is false, and we are asked for a counterexample. So let's go the center. Okay, so the center plays football, is not the quarterback. And that is the conditional and the converse. Now, when we're talking about the inverse is written like this. And in addition, most of the things we see are if something is true, then something else is true. If something A happens, then something B happens. If you are this person, then this is true. That's what we've been dealing with. There are also negations. And negations simply say if something isn't true or doesn't happen. And so here, what we're going to do, the inverse is what happens when, let's take a look back at our conditional, if P, then Q. So now we're just going to go, if not P, then not Q. So that would look like this. If you are not a quarterback, then you do not play the football. So if you're not a quarterback, then you don't play football. So again, we're going to look at this and we go, you know what, that's false. And it's false for the exact same reason that the converse was false. There are lots of people who do play football. So if you look at the entire group of people who are not quarterbacks, and you ask yourself, do any of those people who aren't quarterbacks, do any of them play football? And you go, yeah, a center plays football. A center's not a quarterback, so that's a false statement. So notice that what we did is we took this right here, our conditional, and we negated both sides of it. And that's our inverse. Finally, funnest word to say, contrapositive. The contrapositive, everyone say it with me, contrapositive, good job, is negative Q goes to negative P. If not Q, then not P. So this would look like this. Now notice that we have the setup here of the converse. And what we're doing is we're negating the converse. So we go over here. The contrapositive, if you want to think about it this way, is kind of like a double negative. We flip around our conditional, and then we negate it. So it's going to look like this. If you do not play football, then you are not a quarterback. And that, my good friends, is true. Only quarterbacks play football. So if you don't play football, you can't be a quarterback. Now notice that the conditional and the contrapositive have the same truth value. So you know that will always be true. It's kind of one of those two wrongs don't make a right, except in this case they do. Two negatives make a positive. You have those that contrapositive making a true statement. And finally, we have 21. Now 21, I'm just going to show you how to put it into an if-then statement, and then I'm going to leave the rest for you. So I have pianists are musicians. And yes, both of my kids just laughed at the word, just Mina? Okay. Just the 17-year-old laughed at the word pianist. She's going to get major giggles when I start talking about it being P too. Okay. So what we want to do is we want to turn it into an if-then statement. We want to be able to turn it into a conditional. And that is going to be if you are a pianist, switch over to our conclusion, that's our hypothesis. So we take the whole group of people who are pianists and we say, then you are a musician. And that is true. All pianists are musicians to one extent or another. You can't play the piano without making music. Converse, you'd want to flip that around. If you're a musician, then you're a pianist. Inverse, you want to negate it. If you're not a pianist, then you are not a musician. And then finally, the contrapositive, you take that converse. If you're a musician, then you are a pianist, and you negate it. If you are not a musician, then you are not a pianist. Now, if you're paying attention, you should be able to see kind of what those truth values line up as, and specifically see that this conditional right here has this truth value, and therefore the contrapositive there at the end is going to have that same truth value. Have any questions? Post them at the bottom. Give me an email, whatever you prefer. Thank you very much for listening, and I will see you next time. Or rather, you'll hear me. I'll see you in class, unless you skip. And don't skip, because that's bad, and you'll get caught. Then you have to go to ALC, and it's a pain in the butt. And then because Miss Anderson like comes around and pulls you out of class and gives you lunch detention, and that's not fun. So I'll see you guys later. Bye.